So I'm gonna give you a tutorial over the API of Fink. Just a reminder, the idea here is to show you a little bit the functionalities with multi-messenger and multi-wavelength astronomy. There will be another in supernova and extragalactic transients later on today. But Fink has different communication channels. So one of them is the API. The other one is the Fink science portal that you can find here in the webpage. And both come from a database that actually is not real-time based. We usually, the real-time based analysis is sent in streams that you can receive if you want to receive them. Just contact us for that. But this is the data that is aggregated at the end of the night. So you need to wait till the end of the night of observations to actually get this. So the center here in this tutorial is more about how to do some analysis with that data and to see a little bit the functionalities that we have right now. And if you have any suggestions, we're open to hear it. So I'm gonna try to run this live. So what is behind? Basically, there is Fink cross matches all of the alerts that enter and pass the quality codes with the Sinbad catalog using a 1 arc second radius using the cross match service. And then we have a series of machine learning classification algorithms that I'll show you a little bit how they work, and some extra features that we compute, like color and rate, when possible, of course. So first of all, you set up the environment, you show packages, pandas, numpy, and now we're gonna do our first query. The first query will be simply, let's find all the alerts, the latest alerts. So this is the API that you want to use. We want to query for everything that we have tagged as kilonova candidate. This is a tag defined and provided by us. Usually it requires that there is no transient association from catalogs, is relatively new alert, and that our machine learning algorithm thinks that it's a potential kilonova, of course. And here I'm querying 20 alerts. And just because of reproducibility, we put a start date and a stop date. So we would have exactly a nice candidate to show, but you can take this off and you will have the last 20 alerts of today. And then we're going to convert it in pandas because I love pandas and it's a great tool. So if you have questions, you can take a look at this link to see how the structure of the query is. Now we have a pandas data frame, which you should see here right now with the cross match in CDS, with the score that we provide the kilonova and a lot of different things. These are mostly machine learning things, but these are inputs from CTF. Now, maybe you want to take a look of the scores of these alerts, all these machine learning classifier that we have. You can see that the alerts have a distribution of a score. So maybe you want to center just in the high probability kilonova, but maybe you just want to see everything. So another question that you could ask is, well, kilonova at the beginning may look a little bit like supernova. So can we see if there are also candidates for supernova in the machine learning algorithms? And this is what I'm showing here is basically the score. So the supernova is SNN. There are two super and nova algorithms that are working here, and a random forest. And so yellow, green, and red are supernova, and blue is kilonova. So you can see that there is some degeneracy in the scores, but this is maybe something interesting for you to take out the ones that look like supernova. So how many individual objects have been tagged as possible kilonova? You can find it here, all these objects from CTF. Now, maybe you want to take a look at the light curve. You can do this in the science portal, of course, but let's find an object. I'm selecting a single object name that is this CTF object. I query for the photometry because the data that we just gave you were the alerts, but not the complete photometry for that object. So I am carrying basically that and converting it to a pandas data frame, and then we can plot it. So for that, well, I wrote a little code that you can copy paste to plot the data. So this is the light curve that we have. So just to give you an idea, in blue and orange field markers are detections in circles. Upper triangles with errors are alerts measurements that didn't certify are quality cuts, but are used in the machine learning classifier, and all of these that are empty are just limits. Now, maybe you want to see the color or rate of these objects. So we already provide this as something that we compute. This is the rate of increase in the R band, and this is the rate of increase in the G band, and this is the color, for example. And you can see the rate, sometimes you have zeros because you don't have a difference, especially if we're just limits, and you will have nans in the color, of course, if we didn't have two measurements in the two filters in the same night. But taking the ones that are good, we can plot those, and you can see that the rate, for example, of increase in G, you can see this one is not great because it means that it's decreasing. But you can also see, for example, the color. So I will do that right now, live demonstration. So let's see the color up. I have an error because I probably did a mistake somewhere. But I'm gonna continue. I will correct this later. So the second case study I wanted to show you is, let's say you want to find some transients in an area on the sky. So we can do a con search with an API query. So the request is, instead of the latest, you're gonna do the Explorer API, which is here. And you're gonna do a radix and a radius here. And then you do the query, you will get your con search, and it's gonna give you an object here. So of course, there are different things that you can put in here. The schema is in this web page. The third case I wanted to show you is that maybe you have a GRB. So for example, we're working in Kilonova and GRBs with Grandma or SVOM, or let's say you have a detection of a GRB with Swift and you want to see if simultaneously CTF or LSST got something. So the API query will be basically in the Explorer API, and we will put, well, my GRB happened at this date, and I want a window of 1 minute to see if there were alerts. And then I can get that in a pandas data frame. It will give me all the alerts that were around that time. And you can see that some of them are known transients. And this was quite a big radius, by the way. But you can inspect the scores, and you can inspect all the information from it. Now, maybe you want this a time, but you want to restrict the area in the sky. So you have a radix here, and you just put, I want it between these coordinates, and you can decide that, and you can see that there are two objects here. One is a cipher to one galaxy, and the other one is an unknown according to
2 minutes,
CVS.
Anais.
Thank you. And you can see they are actually not very high supernova candidates. So this is something interesting. So maybe that's the object you were searching for. And you want to see maybe if it's the thumbnail, so the contextual information. So what you're going to do now is that you are going to query the API in the object part. You're going to put your object name, and you want to see the cutouts. So here is a little bit of a code that does the plotting, and you can see the science image, the template, and the subtraction. Alternatively, instead of using this, we also have another service that is called the cutout service. And actually, it's quite nice because you can, it looks more of an astronomical image in the color map, and see whether this is the object you were searching for or not. So basically in this notebook, I have shown you how to query Fink's API for latest alerts using science filters, using a cone search, a time window, and getting photometry and thumbnails, and inspecting a little bit all the added values that we provide. I'm going to talk a little bit more on color and rate in the supernova and AGN extragalactic tutorial later on today if you're curious about those quantities. Thank you.
Thank you, Anais. We have no question in the chat. I guess MD Howell is writing something, right? Okay, anyway, we don't have time now. So please, if you have questions, put them on the chat, on the Slack. Thank you.